Hey, so last episode we did a small function to sort of tell the game, well, that it's closed for registration. That means the game can actually start. There's no more players that will be involved in the game. So that was great. So let's maybe compile our stuff, see if it works again. Okay, all the tests pass, amazing. So what are we gonna do today? So today, let's open the test first. So there's something I want to do, which, as you can see in the test, we expose the internals of the game structure, and that's probably fine, but I wanted to explore a pattern called the null pointer patterns. No. What am I talking about? The opaque pointer type. So basically that means we'll have a pointer to our structure, but that structure won't have any members accessible like this, right? So we will need to create some functions, some getters, let's say, to be able to access the value of this pointer. The value, yeah, that is kept internally by this pointer. So basically, the way it's gonna go, so whenever we've got game players, we will transform this with something like, let me do global. So let's replace this with game, and then get players, and then we will pass a game t, or just a game. And yeah, let's go ahead and replace that. Do this. And let's run the test, which is obviously not going to work, but let's see what it's complaining about. It is complaining about the fact that there's no such function, so let's implement this. Let's start implementing this, and let's first of all, how are we gonna proceed? Let's create a function that returns a player t. We're gonna do this in several steps, I guess. Let's start with this game.getPlayers, and that will take a pointer to a game t. Game, there you go, and let's save that, run the test. Okay, cool. So now it doesn't find a reference to this function because obviously we haven't implemented it yet. Let's go open the risk file, the risk.c, and let's create that function. So it's gonna be a function that returns a player t pointer, and it's going to be game get player actually. Get players. Oh, I actually need to rename this. Let's do this. Let's return null for now. And also let's go back to, let's go back to the header file and correct this mistake. So let's rename this to get player. All right. Now we are here, and so this is going to take as an argument game t game pointer, and obviously that's going to get player. Oh, wait a second. Hang on. I'm all mixed up. Not get players. Okay, yes, actually. So yes, I was actually wrong. So that should be get players, which return a pointer to a player t. And then in the risk.c, we're going to do game and on players, and this is return game.players. We could be paranoid and actually handle the case where game is null. So if there's no such a thing as a game, just return null. That's it. And there you go. That should be fine. And let's run our test. Oh yeah, of course, because this is get players. And our test pass. Brilliant. So that's good. Let's go back to now the next function, get player. So same thing, same process for player count, and we will just do a global replace in this file. We are going to replace it with game.player count, and we will pass in the game instance. Let's remove everything and then get player count. Okay, let's run the test. Okay, now we need to declare this function in our source file, in our header file, sorry. So that's going to be, so we're going to return a uint8, and that's going to be game, what was the player count. And we pass in a pointer to the game, and let's run the test. Okay, it's complaining that player count is not finding the symbol because we haven't actually implemented the function. So let's go and add and do that. No, that returns a uint8t game player count. All right. Okay, and then if so same thing, we'll handle the case where game is null and then return null. No, not null, we will return 0, and we will return game and then player count, right? So that looks great. Let's run the test. Wonderful, everything passes. So let's keep cracking. Ready to start. Same thing here. You get the gist, and replace this with is game ready to start, and we'll pass in the game. All right, run the test. All right, let's declare this function in the header file. So is going to return a bool. Is game ready to start? Pass in the game pointer, right? Run the test. Okay, sweet. And risk.c. So it's going to be a bool. Is game ready to start? Pass in the game. And so if there's not such thing as a game, then return false, and then return game ready to start. Run the tests, everything passes. Wonderful. Where is my, oops, I cannot type. I've got a new keyboard, it's slightly larger, so I'm like doing a lot of mistakes when I'm typing, so bear with me. Okay, what is wrong with this? Is game ready to start? So it looks like there's something wrong with the. Okay, no, that's cool. So it's found it. Okay. We do have this one as well, so we need to do the same thing for. This time for the player structure. So we won't expose the player internals of the internals of the player struct. So we sort of need to do the same thing. So black player, So let's do a, can we do a global replace? Oh, actually, yeah, no, let's do that. So that's going to be player get color. Right, and then we'll pass in the black player, and we want to assert that the color of this player is black. Right, so that should be something like this. So let's take this, do the same thing here, passing the blue player instance, do that. Let's go ahead and do this for every player. Okay, and right. And yellow player. Whoops, what have I done? Not that one. That would be this one, and pass in that yellow player. All right. Oops. No. Right. Finally got it sorted. Run the test. What is the user fun declared identifier player color? Great. So I guess we're gonna have to add these to the header file. And we said, and that's gonna return a color, a player color. And this, and then we pass in a player pointer. And there you go, run the test. And it turns out, oh, I just got bitten by a mosquito. That hurts. Turns out I made a boo-boo in the test file. Which line 1, line 36. Yes, indeed, that is not right. There you go, run the test again. And okay, so now we need to, well, sort of implement this function. And where are the players function? Okay, here. Let's go player T. No, that doesn't return a player, that returns a player color. Yeah, that's gonna be player get color. Oh. Get color, pass in a player T pointer, and give me right. So I guess if player is null, oh, that's actually quite interesting. So if player is null, what do we do? Can we return null? Don't think we can. That is interesting. What can we do? So in this instance, I think what we could do in this instance, if the player hasn't been initialized, so we've got this player color, and then we could return a player, or should we add this in here? Like this is gonna be a, oh no, because that's not gonna be the correct type. So what we could do then here is have a no color assigned. Uninitialized, player uninitialized, player not initialized. Okay, so that's gonna, oops, so that's gonna be the, okay. I'm not sure if I like this, but let's roll with that for now. We can always correct this later. So player colors, so not player not initialized. Player not initialized, okay. Otherwise, return the player color, right? And also add a little return statement. Brilliant. Let's run the test, and the test pass. Awesome. Let's go back to our test. And there is still a slight problem with this. So if I take the game here, then you can see I still have access to those properties, which I really shouldn't. So we need a way to mask those properties. So the way you do this, as far as I understand, and I think I understood it correctly, we're going to take our player T and game structure. We're going to shove those in the risk.c. Put them at the top of the file, such that this makes those structure private to this file, and we're going to rename those probably like player private, player instance. I have seen this in a while where they would name instance those the private structures. And so actually I think you just do this. I don't quite remember yet how to do this, and this isn't actually a type def, that's just a normal struct without defining a type, and this actually then turns into a struct player instance pointer. And the way we are going to expose this is here in our header file, define a type def struct, and that we are going to have a game type, which is going to be a game t, which is going to be alias to a game instance t pointer. I believe that's how it works, and we should do the same with the player, and that's going to be a player instance t. Yeah, I think that's how it works. It could be the other way around. No. So you define it is a struct. I can never remember which way it goes. But this means then that we will be dealing, instead of dealing with pointers, we will be dealing with plain objects, like the sort of passing a pointer. We're going to pass by value the game to the function. So I believe that now we can turn all of those like this, and pass player and a game like this, and also they won't return pointers anymore, they will just return this, and okay. I'm actually not quite sure what's going on here, if I'm doing this right, but let's explore. All right, so game creates, that should return a game. So I think I got the structure declaration the wrong way around, because you can tell that all the squiggly, the LSP isn't quite happy with that. But that's all right. We've got test for that. So actually, let's reverse this. No, yeah, that is not how that works. I think that works like this. Let's compile, and it's still not happy. You must use struct tag to refer to type game T. Okay. Type the struct. Does this actually need to be a struct? Yeah, that does need to be unknown type. Well, yes, that's how it works, I believe. No, it's still not quite happy. Would that be a pointer like this? Let me Google this. See, opaque pointer, opaque type. Practical design, okay, cool. And let's go zoom a bit. Okay, time to struct, yeah, so you define, yes, okay, cool, yeah, that's how it works. So, yeah, you need to add the struct here, but your private thing is that you're aliasing a pointer to the struct to the game type. That should do the trick, and the star is here, right? And here it looks a little bit better. I think that now, let's see what happens if we run the test. Yeah, so conflicting type, that means then there you go. Now we do need to do that. And so instead of accessing it this way, we now access it with a dot. Or do we? No, I think. Why would that worked? Or do we use struct game instance, I think, in the actual implementation? Game instance T pointer. Has an incomplete type. Or should just type def this as well. Type def struct. Type def struct. I mean, I should have prepared this a bit more. Incomplete game instance T. Okay, so what's the error here? So we define a pointer to that struct. Is this that I need to do that? Oh, yes. Okay, cool, yeah. That was the problem. So yeah, there you go, that fix it. So here we need to do the same thing here, and that's going to be this. That's going to be a player instance T pointer. Oh, could we actually just do this? Yeah, I think that works as well. Yeah, that works. That works. And that's going to be then, and here you can actually just use game T game. And that does the trick. Yeah, that does the trick. We're fine. We are fine. Why this works is that because this is private, so it knows how to resolve game player, because it knows in this module, the C code, the compiler knows that a game T value is just an alias for this, right? So bear with me a second. Let's do all the necessary modifications. So this no longer needs a star. Let's remove the star there as well. And there. that's one of the benefit of using opaque pointer, is like you sort of remove the fact that you're using pointers from your function interfaces, which could like somewhat be confusing to people. I don't know. I'll just find it neat to not pass pointer to function. And anyway, I wanted to sort of explore as well this this pattern. Let's go back to our test. Where's our test? Our test is here, and ooh, it doesn't seem to be very happy about that. Right. I guess maybe I just need to restart the LSP. Okay, game. Okay, I thought we forgot to change this one. So is game ready to start? Right. That shouldn't be starting. Okay, cool. So that looks fine, and all our tests pass. Wonderful. Now let's verify that we get an error. Let's say we're trying to do this, and then you can see that there's no such thing as we cannot access like players, for example, directly. So if we were to do something like printf, what is this? Printf person like the players, person p, and sort of like try to point the pointer to the game players. Print the pointer to the game players, and you'd see it's like it's not even going to compile, but let's just run it for the sake of it. Yeah. It's like, oh yeah, there's no such thing. What I'm slightly puzzled with is the error message strip game instance C. I wonder whether there's a way to make the compiler, because that might be confusing the user. Oh, I've got a game T, but the type is game instance T. But yeah, maybe that's just one of the weirdness of the patterns. But let's leave it there. I think it's quite good. So as you can see now, we've got a game. We're just passing instances of game by value to functions like this, and there's no pointers involved, and so maybe it reduces a bit the confusion when somebody's trying to use your API. Yeah, that's pretty much it. I quite like this. I'm gonna leave it there for this episode. And this episode, I think next episode, we won't do any more refactoring, and we will go a little bit further in implementing the game. So then the next step of the game will be to, when the game is ready. So in fact, when we call the game player registration closed, at that point we know the numbers of players, and in the risk game, when you have determined the number of players, you need to sort of give players a certain set of pawns. So if we scroll down a bit, there is a chart. So yes, if we're playing with two players, it's a bit the rules are a bit different. But if you have a 3-player playing, then each player should receive 35 infantries. 4 should receive 30 infantries. So when we close the registration, when we close the game for player registration, we should also assign armies. So basically, we do something along the lines of game at player game red. So we could do so that's going to be a player T player. So let's call him the red player, just like using the same thing. And then we should be able to do something like get along the lines of game, player, get infantries, count, get infantry counts, infantry count, and that should return, and then we should expect that this is equal to well, 35 if we add more players, right? If we were to add 3 players. But I'll leave this for next episode, and that's it for this episode. Thank you for watching, and we'll see you later.